Hello viewers, welcome to my channel once again. In this video we want to treat factor theorem as the continuation of our topic polynomial or polynomial function. If you are new, please consider subscribing to the channel, like and share after you watch this video. So we are saying that a factor theorem is saying that this is a theorem that states that given a given polynomial, that is p of x, of a certain degree greater than what? 0. So the degree could be 1, 2, 3, 4 in that order. It should not be 0 or a negative answer, or it should not be fraction. So if we have p of a, that is the x being replaced by a, give us 0, then we are going to say that the x minus a, this could be setting this linear as a 0, meaning x minus a equals 0 will give us a. If that is the case, then this particular linear function is a factor of the polynomial given to us. In other words, we can say that if x minus a is a factor of the polynomial, then the zeros of the linear should give us 0 of the polynomial. What I mean is that if I have any polynomial p of x equals to, let's say, x to the power 3 plus 1, and I'm asked to find a factor of this, we are looking for a number that will replace x with. We are looking for a number that if I replace x with will give me the whole of this to be equal to 0. So in this case, if I set x to become -1, I'll be having -1 all cubed plus 1. Seeing this is an odd number, the negative number will still be in the answer. So I'm going to have -1 plus 1, which is what? 0. So if this is the value of x that make this polynomial to be 0, it means that x plus 1 is a factor of this polynomial. How do we get this? This is from the zeros of this linear equation, meaning setting this equals to 0 give us x equals to -1. That was what was placed in place of x. So for any factor, if you divide the polynomial and you get 0, it means that number is a factor of the polynomial. So what we are having here is that we have to show that x plus 2 is a factor of this given polynomial. Simply put, if we divide this polynomial by this, we should have 0 as the remainder. The remainder should be 0. It should be able to divide that. So what we do is that if you want to follow the idea of this, p of a equals 0, then it means that we need to get the a from this particular linear function, meaning x plus 2 must be set equal to 0 in order to find the x to be a. So this will give me x equals to what? -2. So this is now become the value of a, which will replace your x in that function. So that will become, if this is f of x equals to x3, so if you are letting the f of x to be our polynomial, then our f of -2, we want to see whether we will get 0. You must get 0 to prove that it is a factor of that. So -2 all to the power 3, 2 -2 squared, 5 -2 plus what? 6. We've replaced all the values of x. A power of 3, meaning that we are still going to have a negative. -2 times -2 times -2 will give you a negative value. So that will be -8. This is going to be -2 squared That will be a positive 4. Positive 4 times 2 will give us positive negative 4, 8, as in this negative. Negative 2 times negative 5, positive 4, 10. Then plus your 6. We know these negative values are going to give us negative 16. Then these two will give us what? Another what? 16. So negative 16 plus what? 16 will give us 0. So therefore, x plus 2 is a factor of the function that we have, which is this relation. So for you to find the factor of any polynomial, just the divisor given to you, set that divisor equals what? 0. If you set the divisor equals 0, the value of x will be placed into the polynomial. If you get 0, then it means that linear function is a factor of the given polynomial.